So, you're thinking about a career in cybersecurity. It can definitely feel like a huge, complicated world. But, like any big journey, it all starts with that very first step. And for a whole lot of people, that first step is the Certified in Cybersecurity certification. In this explainer, we're going to give you the map to get started. Okay, let's jump right into the blueprint for the exam. The whole certification is built around these 5 core areas or domains. And right away, you can see that security principles and network security are the heavy hitters. I mean, together they make up literally half the exam. But don't sleep on the other areas. Every single slice of this pie is a critical pillar you need to build a really solid foundation in cybersecurity. So here's our game plan. We're going to walk through each of those 5 domains, one by one. Our goal is to give you the high-level view of exactly what you need to know to crack this code. Let's do it.
All right, let's start with the biggest piece of the pie, security principles. Now, this isn't just some random list of ideas. This is the absolute bedrock. Everything else we do in cybersecurity, it's all built right on top of this foundation.
At the very heart of security, you'll always find what's called the CIA triad: confidentiality, integrity, and availability. So let's start with confidentiality. The goal here is pretty simple. Keep private information private. The best way to think about it is like a sealed envelope. Encryption is that wax seal, making sure only the right person can actually open it and read the message inside. Next up in our triad is integrity, and this is all about trust. So, if confidentiality is about who can see the data, integrity is about knowing that the data you're seeing hasn't been messed with. It ensures nothing has been changed, added, or deleted without you knowing. Kind of like a digital tamper-proof seal on a document. And the final piece of the triad is availability. Because let's be honest, what good is your secret, trustworthy data if the people who are supposed to use it can't get to it? Availability is all about making sure systems are up and running for authorized users when they need them. It's like making sure a store is actually open for business during its advertised hours. Every single security decision we make is a balancing act between these 3 core principles. So why do we even need these principles in the first place? Well, it's all to manage one thing: risk. In the world of cybersecurity, risk is the potential for something bad to happen. But it's not just a vague, scary feeling. It actually has a very specific formula.
And this diagram? It shows you that formula perfectly. See, you have an asset. That's the valuable thing you want to protect. Then you have a vulnerability. That's a weakness in your defenses. And finally, you have a threat. That's someone or something that can take advantage of that weakness. The area where all 3 of those circles overlap, that is where you find your risk.
And to manage that risk, organizations use a continuous cycle, something like this risk management framework. It's really important to know this isn't a one-and-done kind of thing. It starts with preparing and categorizing, you move into selecting and implementing your security controls, and then you enter this constant loop of assessing, authorizing, and monitoring to make sure everything stays safe over time. Okay, let's move on to our second domain. Because no matter how well you manage risk, let's face it, bad things can still happen. And that's where business continuity comes in. It is all about having a plan to keep the lights on when a crisis hits. Now, people mix up business continuity and disaster recovery all the time, but they're definitely not the same. Think of it like this. Business continuity is the big picture, strategic plan to keep the entire business afloat. Disaster recovery is a super important part of that plan, and it focuses specifically on the technical steps to get your IT systems and data back online. Next up, access control. This is one of the most fundamental concepts in all of security. At its core, it's all about answering one simple question: who is allowed to do what?
Access controls really come in 2 main flavors. You've got your physical controls. These are the things you can actually go up and touch: locks on doors, security guards, fences. And then you have logical controls, sometimes called technical controls, which are all the digital barriers, passwords, user permissions, firewalls, all the stuff that controls access in the world of code.
So how do you decide who gets access to what? Well, you follow a golden rule, the principle of least privilege. This is so important. It just means that you give people the absolute minimum level of access they need to do their job, and not a single permission more. This one simple idea dramatically reduces your risk. All right, let's get a little more technical with our 4th domain, network security. Data is constantly moving around us, and our job is to protect it while it's in transit, whether it's just flying across the office or all the way across the globe.
Have you ever really stopped to think about that? I mean, when you click a link, what is actually happening under the hood that lets your computer talk to a server that could be thousands of miles away? The answer lies in a set of standardized rules, or what we call models.
The answer is a standardized framework called the OSI model. It's a 7-layer conceptual blueprint that takes the incredibly complex process of network communication and breaks it down into simpler, more manageable chunks. It covers everything from the physical wires at the very bottom all the way up to the software application you're clicking on at the very top.
Now, here's where theory meets reality. While that 7-layer OSI model is the universal theory, it's what you learn in the textbook, the internet actually runs on a more practical, condensed 4-layer model called TCP/IP. You can see right here how the layers map to each other. It's a perfect example of how a theoretical idea gets adapted into a real, working system that powers our entire digital world. So to talk on a network, every single device needs an address. For decades, we used something called IPv4, which gave us about 4.3 billion addresses. And that sounds like a lot, right? Well, we ran out. That's why we moved to IPv6, which gives us, well, 340 undecillion addresses. That's 340 with 36 zeros after it. The bottom line is, we are not going to be running out of those anytime soon.
And that brings us to our final domain, security operations. This is where the theory hits the real world. It's all about the daily, hands-on practices, procedures, and tools that keep an organization safe and secure.
A huge part of security operations is data protection, and a cornerstone of that is backups. As this diagram shows, you have different strategies. You can do a full backup of everything, a differential backup of just the changes since the last full one, or an incremental backup of changes since the last backup you did of any kind. A really solid strategy that combines these is absolutely non-negotiable. But look, technology is only part of the solution. You also need really clear rules for people. Essential security policies govern everything from what is considered acceptable use of company equipment to how strong your password needs to be. These are the documents that guide behavior and make sure everyone is on the same page.
And there you have it. From the foundational principles of trust, to planning for disaster, controlling access, securing the network, and running the daily defenses. We've really gone from the blueprint all the way to the finished building. These 5 domains are the absolute core of what cybersecurity is all about.
The Certified in Cybersecurity certification really gives you the foundation for all of them. So the only question left is, now that you've seen the blueprint, which part of this digital world are you most excited to start building and protecting?